Welcome to CEC live lectures. So in the previous lecture we were talking about computer networks and we had discussed the different aspects of a data communication system, and we were talking about the physical structure of a computer network. In that we were talking about the different topologies. So today we will talk about star topology. So star topology is a topology in which all stations are connected to a single hub. Right. So, and there is no dedicated link between any two stations or any two devices. There is no link in fact between any two devices or nodes on the network. In turn, all nodes or all stations are connected to a single hub, okay, which could be a switch in this case. Okay. So, this hub connects all the devices, and therefore, in this case this acts as a central controller, because there is no point to point contact. So, this hub acts as a central controller and devices are connected only to this. So, therefore, there is no direct traffic between the devices and all traffic is coming to the controller in this case. So, definitely this is less expensive than the mesh topology, because we had seen that in a mesh topology how much wiring is required, how much IO ports, and it becomes prohibitively expensive. So, in a star topology every device will need only one link, that is only one IO port to connect to any other number of nodes, because the device only connects to the hub. In turn, the hub connects to multiple devices. So, therefore, it is also very easy to install and reconfigure, and it requires less cabling. So, this is very easy. Addition or deletion or moving or making any change will be very easy, because there is only one connection which is there between that device and the hub. Right. So, if one link fails, only that link is affected in case of the star topology. All the other the links will remain active. So, this factor also lends itself to easy fault identification and fault isolation, because for the network administrator he has to only check the hub, and from the hub itself he will get the knowledge that which device is failing and the fault is occurring at which point in the network. So, as long as the hub is working, the hub can be used to monitor all the problems and also to use to bypass any kind of defective links which are there. So, through the hub the entire network management and administration becomes much simplified, right. But the biggest disadvantage again depends on, because there is a dependency on the single hub. So, therefore, if the hub goes down, then the whole system is dead. Right. So, it requires less cabling, but then it is also less secure, because all data is trafficked to the hub, right. So, the cabling is required definitely, because the cabling it goes to the hub, all the devices are to be connected to the hub. So, lesser cabling, but still cabling is required. There are other topologies which we will be studying which require further less amount of cabling, and of course the biggest disadvantage is dependency on a single switch or hub. So, the next topology which we see, which is a simpler topology, is the bus topology. So, in the bus topology we have a single main line, or which we call as the main channel, and all the devices are connected to this main line through the drop lines and through the tap. So, tap is basically the point which connects the devices or the drop lines to the main line. So, in this case there is a single backbone which runs, and through this backbone all devices will communicate with each other, right. So, in this case there is one long cable and all the nodes they are connected to this single long cable, right. So, it runs from one end to the other, right, and the main cable, or the main cable is connected to the tap, because the tap is acting like a connector which between the different cables. So, bus topology is generally we are looking at bus topology in the context of a wired network or a wired LAN. Okay. So, when the signal is traveling on the backbone, then of course there is a problem that energy is getting transformed into heat, because as I just told you that bus topology is being looked at in terms of cable, right. So cables are basically metallic wires. So when a signal or when data flows through them or energy flows through them, so there is, the wires get heated up and some amount of energy is lost, and because of this loss of signal or loss of energy, the signals will become weaker and weaker. So as they travel along the backbone, the signal becomes weaker. So therefore, there is a limit on the number of taps a bus can support and on the distance between those taps, because beyond a point, the signal will become so weak that it will not be transmitted. So the bus topology has the biggest limitation upon on the number of systems which are going to be connected to the tap. Of course, there is no denial that this is the very easy topology in terms of installation, right. The backbone can be laid on an efficient path and all the nodes can be connected to this backbone, right. Though there is no problem of redundancy, it is much cheaper than the other two, because there is no need for buying an expensive hub, there is no need for that kind of redundant wiring which is there. So it is much cheaper, it is much easier and easier to install, easier to maintain, right. So it's only the line which needs to be drawn is from the backbone to the nearest point. But the disadvantage is that one is that if there is a breakage in the bus or in the main backbone someplace, right, so then it is very difficult to keep the network going, because if the network can then be divided into two segments, right. And also the bus is usually designed to work at optimal efficiency is maintained at the time of installation. But if new devices are added to the bus, then it will be very difficult because of obvious reasons of the signal drop which is going to happen. So signal reflection is another problem which happens here, because of which the quality of signals gets degraded, because when the taps are very close to each other, so the signals they sort of tend to leak, and there is a problem of noise and attenuation which can occur, because the spacing can be an issue because of the length of the cable. Sometimes the taps and the links are to be placed very closely to each other, so that can lead to a problem of signal corruption sometimes. Okay, and as already discussed, that adding new devices is always a problem in case of bus, because when you break a line, when you break the bus or a fault occurs somewhere, then the new devices to be added or the damaged area, it again reflects the signals back in the direction of origin. So there can be a massive problem of noise which can occur in both directions when we are using this kind of bus topology, right. So the next type of topology which is also very commonly used is the ring topology. Now the ring topology is it's an enhancement in the bus topology, because in the bus topology we had terminators at both ends of the cable, but here the signal, the single bus has been connected to form the ring topology. So instead of tap we have another sophisticated device here which is known as the repeater. So the repeater will perform the function of signal regeneration, because we had seen that in case of bus we saw that the signal gets weakened because of heat and because of reflection, there is a problem of noise in the signal or corruption of the signals. So all those points are taken care of when we are looking at the ring topology. So in case of a ring topology, every device has a dedicated point to point connection with only the two devices on either side of it, right. So the signal basically it flows in the ring style in one direction from device to device until it reaches its destination device. Okay, so each device in the ring is of course is have a repeater, and this repeater will basically regenerate the bits and pass them along, so that the signal doesn't get weakened while it is moving on the particular wire or the ring. So ring topology is also easy to install and reconfigure, and because every device needs only two connections. So therefore it is very easy, you can add or you can remove the device, there is not much constraint. right. So, you only have to see that the ring also has a limitation of maximum length and the maximum number of devices to that you can connect in that particular ring, right. So, in addition, fault isolation is also simplified in the ring because a signal is circulating at all the time. So, if one device does not receive a signal within a specified period, then that device can issue an alarm, and that alarm will alert the network operator to the problem and its location. So, because the signal is moving continuously in the entire ring. So, we say that there is an advantage, but there is also another disadvantage which occurs when we are talking about unidirectional traffic, that in a simple ring, the break in the ring such as disabled station can disable the entire network, right, because one link, if it is not working, then it will not work. But for this there is a solution which has been suggested, that is called the dual ring network. So, in that case, even if there is one break, so the redundant ring will become functional and then your ring topology will start functioning again. So, it was prevalent when IBM introduced the local area network, the token ring network was very popular. Okay, but this topology has become less popular now, because now the expectation for the LANs is higher speed, and therefore the token ring network has now been sort of becoming redundant. So, now we look at the fifth type of topology, which is called the hybrid topology. So, if you can see here also, it is shown in the diagram that the hybrid topology basically combines the features of two or more than two topologies. So, here you can see that 3 bus topologies are combined together using the hub to form a star topology. So, in this is a combination topology which we are looking at, which incorporates the feature of the bus topology also and the star topology also. So, on every node basically from the hub is actually connecting multiple systems through a single backbone. So, this hybrid topology is the most popular topology, and actually these days this topology is used in maximum type of network, because node topology is used in isolation as to combine the advantages of different topologies and creating or building up larger networks, right. So, this is about the topologies that we were talking, that what are the different ways, what are the different methods in which physically the networks can be created, in which physically the devices can be laid down to build good networks, right. So, there are different types of networks also which we see depending upon the geographical spread of the network. So, the most popular 3 networks which everybody of course knows is the local area, the wide area and the metropolitan area network. So, commonly these are known as the LAN, the WAN and the MAN networks. Of course, these days people also talk about a PAN network, that is personal area network, but that is basically not considered as a proper network, because that is a network which is temporarily created between only 2 devices, and there is not much network administration and management which goes into it. So, that we will keep that as out of scope of this lecture, but we will be talking about the LAN, WAN and the MAN networks. So, it is important to understand the characteristics. So, first characteristic which distinguishes these 3 is of course the geographical spread or the size of the network or the span of the network. So, as we all know, local area network, they are spread through short distances, wide area network can be long distances even up to the entire world, and metropolitan area network, they provide connectivity over areas such as a city or a particular campus. So, local area networks, they are the basic purpose is to provide local interconnectivity within the particular a particular building or a particular smaller area of a few kilometers. Wide area network provides connectivity to larger areas, it can be globally also, and of course metropolitan area network is for a particular within the geographical area of a metropolitan city or that. So local area networks, these are generally known as LANs, and the main important characteristic is that these are privately owned networks, okay, and they belong to a particular institution, they belong to a particular company, maybe a school or a college or a university, right, or a particular office. And the main idea is to share resources, like for example in computer labs, in educational institutions, or in offices also we see that they share printers, right. One printer is connected to multiple machines. So that is one simplest example of LAN which we see all around us, right. And of course information exchange happens through LAN, because these LANs, they are smaller in scope, they connect computers within a particular building. So the information exchange becomes much faster on a LAN. So LANs are distinguished based on their size, the technology and their topology. So there are three characters which which will define how LAN is different from the other networks, right. So in a bus network, LAN is generally used, constructed using a bus network or a bus topology, right. So it allows one machine become the master and is allowed to transmit, and all the other machines, they refrain from sending any data. So one machine at any given point in time, one machine will send the data, the other machines will receive the data, okay. And if there is a conflict which occurs when two or more machines want to transmit the data simultaneously, then there are certain arbitration algorithms which are used to resolve those conflicts, to make sure that only one device or only one node acts as the master, right. So the Institute of Electronics and Electrical Engineers, they have given a standard which is known as the Ethernet standard, okay, and it specifies and it gives the standards according to which a LAN can be constructed, right. So basic format according to which a LAN can be constructed. So this is, Ethernet is basically a bus based broadcast network. So this means that every node can send the message or can send the data to every other node on the network, right. And there is decentralized control, because every node is capable, or every node is authorized to control its own sending mechanism, and the speed at which this LAN works is around 10 Mbps to 10 Gbps, right. So whatever the computers want, whenever the computers want to share the data, they can share it directly on the Ethernet, right. And when there is a collision, say for instance at the same time two computers are sending the data on the Ethernet, then the computer will wait and for a random time, which is again specified by the collision resolution algorithms, and those after that they will retry and send the packets over the LAN again. So LAN architecture is basically very simple architecture which allows bus topology, and in that the system or the way or the process of sharing data or communication between the devices is also quite simplified, right. So different LANs we can build a LAN using a hybrid topology, as we had seen earlier also. So you have bus topologies, and the buses can be then connected to a simplified hub. So the LANs are basically used for simple communication within a constrained physical geographical area, right. Then of course we have the wide area network. So the wide area network, basically it is a network in which the geographical area is not specified. It is a wide area network, means it can span countries, it can span continents, it can span the complete globe also for that matter. So in case of WAN, we have different systems, and these systems can be connected using two methods. Basically the methods could be, they can be connected through a point to point network also, or they can be connected through a switched network also, right. So it's very important to understand what is a switched WAN and what is the difference between the switched WAN and a point to point WAN. So basically, what is a switched WAN? In case of a switched WAN, the network or the devices, they are not connected to each other directly. In fact, they are connected to switches. So what is a switch basically? A switch is a specific device which will, ensure that there is connection established between two devices when they want to communicate. And once the communication is finished, once the communication is completed, then the connection is also ended. So there is the switches, of course they have a dedicated connection between them, but there is no dedicated connection which exists between the two end system. So you can see, if a device A wants to establish a connection with device B, so in this case they will talk or they will communicate through the switches which are there, right. So this can work between different cities also, this can work between different countries also, right. And then the next type of wide area network is basically it is a point to point WAN. Point to point WAN means that how we are connecting this network, how we are connecting this particular device to another device. So you have one modem which you put at your end and the other modem is put on the other end. So what you see in this example is basically the two modems which are connected, and one modem belongs to the user computer, the other modem it belongs to the internet service provider, right. So this is common way in which we get internet connectivity in our homes. So we have a wireless modem or a wired modem, whatever, and through that we connect to our service provider. So this connection is always like this is like a dedicated connection between these two devices. So generally we see that a wire is coming to our home, and from that wire we are getting the internet connectivity. Okay, so this network and the switched network, they are different in their functioning and they are different in their architecture, because here in the dedicated or in the point to point network the connection always remains, whereas in case of a switched WAN there is no dedicated connection, it is created and it is destroyed. So therefore this is the switched technology is another type of technology if you compare with the point to point technology, right. The next type of network which we need to understand when we are talking about WAN, because the most popular wide area network that we talk and we know about is the internet, right. So internet basically, internet word comes from the word interconnected network, right. So internet can mean the internet which we understand, which provides us global connectivity, which is related to the email and which is related to all the HTTP hypertext transfer and all those things. But there is another there is another way in which internet needs to be understood, that this internet basically it is the internet with a small I. So it means that you are connecting different networks to form a single network. So let us take an example of a small company, say for example, and the company the company has got multiple offices, right. So each office, the offices could be situated in the same city or they could be in another cities also. So you have in different buildings you have individual local area networks. So you can see that local area networks, they are connected. The local area networks could be different topologies. One could be a star topology, the other could be a bus topology, and then these are connected using routers. Now router is another device which is used for connecting different networks together. So using the routers you connect the local area networks to a switched WAN, right. So the WAN may be used, or the wide area network may be used to connect the different LANs which may be residing in the same geographical area or it may be in distant geographical area, and then this WAN is connected to the final thing using a point to point connection or using the using the modems, right. So basically interconnected network means that you are connecting different types of networks using different types of networking devices. So you are connecting local area networks, you are connecting the wide area network, and in between you are having the other devices called the, like for example, you can have a switch, you can have a bridge, or you can have a router. So basically what is the purpose of a router here? The purpose of the router is to provide the best possible route for the packets to transfer, right. So when one computer or when one LAN segment is sending the data to another network, say they are sending it to another LAN or they are sending it to the WAN, so then the router will make sure that the packet reaches the destination computer through the shortest possible path, through the most efficient path. So how does a router ensure that, which is the shortest path? So the router basically, it works at the network layer. Okay, when we talk about protocols, we learn more about it. And the router, it maintains a data, it maintains a table which is known as the routing table. So in the routing table, basically it stores the path from every node to every other node on the network. So whenever a packet is to be transmitted or whenever a packet is to be sent from one host to any other destination, the router will refer to the routing table, and from there it will find out the shortest possible route and it will send it. So the whole idea here is that, the interconnected networks or the networks which are formed using multiple types of networks. So those networks can also be considered as internet. So this internet what we are referring to is the internet with a small I. In the books when we will read the word internet is written in two ways. One is with the capital I. Capital I internet of course refers to the wide area network which is used for global communication. But when you see the word internet written with a small I, then it will mean that it is a segment or it is a network which is, which has been connected using different types of networks. So this internet can belong, the small I internet can belong to a particular company, it can belong to a particular institution, it is like, a private network. So different offices of say a bank, or it can be different offices of a company. So they connect each other and they create this kind of an internet architecture. So this is very, very important to understand that how this, connectivity has been built using the multiple types of networks in the entire scenario of the networks. So this will be all for this lecture. We shall be continuing with this series in the next lectures also. So till then, please keep watching. Thank you so much.